I recently watched a YouTube video by Paradox Gaming entitled How Players Broke the Sound Barrier in Tears of the Kingdom, wherein the creator of the video attempts to launch Link as fast as possible. Now, he gets 2 launches. The first one, he records the data for, but it doesn't quite reach the top of the world. The second one does reach the top of the world, but he doesn't record the data for it, but that was the faster launch. So, what I'm trying to do is figure out how fast the faster launch was. And so we can do this using some basic physics. So, that's exactly what I'm going to do. But first, we need to figure out what equations we're going to use and what variables we know. So, we actually only have to use one equation for this. And that equation is going to be distance traveled equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. So, how do we use this? Well, we're trying to find initial velocity of the second run. But before we can do that, we need to find what A is. So in order to find A, we have to use his first run. So let's do that. So in his initial run, his velocity, in frame 1, his initial velocity is 17 meters in 1 frame, which since the game runs at 30 frames per second, you can multiply that out, 17 times 30, to get that Link is traveling vertically at 510 meters per second. Now, we need to figure out the distance that he traveled. So, he traveled from 1025 up to 3160, so adding those together gives us 4,185 meters traveled. So, let's write that in. 4185. And now the time, this is an approximation since there's a loading zone in the middle, the game hitched, but the first time zone was 3.56 seconds, the second one was 13.37 seconds. Adding those together gives us 16.93 seconds. So now we need to figure out our A value, so let's do that. So 4,185 equals, our initial x is 0, so we don't have to worry about that, plus 510 times time, plus 1/2 A, there's our variable, times squared. Now we just have to run the math on this, so let's do just that. So 510 times 16.93, 16.93 is that. We're going to 4185 minus answer. There we go. So now we're going to multiply that by 2 to get rid of the 1/2, and we're going to divide it by 16.93 squared. And once we do that, we get that our A is equal to negative 31 meters per second squared. Alright, so perfect. Now that we have that, we can figure out what the initial velocity is of the second run. So we pretty much have to set up the same equation. So x equals x initial plus initial velocity times time plus 1/2 at squared. We know that our total distance traveled this time is a little different since it went to the top of the world. It went a little further. So it's 4,317 as opposed to 4,185. And we know that our time, again, has the same thing where it's kind of split into 2 segments, but adding them up, I got 13.37. And now we know that A is negative 31. So now we run it again. 4,317 equals 0. Again, our initial position doesn't really matter. Plus our initial velocity times time, but that's what we're trying to figure out. Plus our 1/2, negative 31, and then our t squared, 13.37 squared. And now we just have to do the math on that. So let's do that. So we're going to first calculate this part. So 0.5 times negative 31 times 13.37 squared is going to give us that number. So now 4,317 minus that, divide that number by 13.37. That gives us a vertical velocity, V0, of 530.1 meters per second. So now that we've figured out the initial vertical velocity, we can use the same calculations that Paradox Gaming used in his video to figure out the final velocity in meters per second and in Mach, how fast Link went. So we know that our velocity, vertical, is 530.1 meters per second. And so now I'm going to use the same horizontal movement that was used in the first launch, since we have no real way of calculating that in the second launch. So let's put up the vector here. So that would be -4, 5, and we have to divide this number by 30 to figure out how many meters he moves per frame. So divide this by 30, we get 17.67. So that's our velocity vector in all three directions, of course. So now we need to do some math to get just one number saying how far he went. So to do that, we're going to use the Pythagorean theorem. So -4 squared plus 5 squared, oops, that should be up there. -4 squared plus 5 squared plus 17.67 squared. So now, let's run this. So -4 squared is going to be 16, 5 squared is going to be 25, plus, unfortunately I don't know this one off the top of my head. So that is going to be 353.2289. Now let's take the square root of that. And we get that Link's final overall net velocity equals 18.794 meters per second. Or that's meters per frame. So now we take our 18.794 meters per frame, multiply that by 30 frames per second, and we get times 30. We get that Link is moving at 563.83 meters per second. So now we're going to divide that by 343, which is the speed of sound, and we get that Link is moving at 1.64 times the speed of sound, aka Mach 1.64.